So again, let's re-emphasize the fact that if something divided by 2 equals 10, then doubling what we get after we divide should give us the original number back again. Now, again, the way you've probably learned it is if you have 10 equals x over 2, you just multiply both sides by 2 over 1, and you get x equals 2 times 10, which is the same thing you would get by thinking about it logically. So whenever we say clear the denominator by multiplying both sides by it, we're really just doing this. We're really saying that if x divided by 2 equals 10, then the denominator times the result must give me the numerator. And then finally, we just need to solve the equation from there. Now we'll just show how to do it, and then we'll move on to doing some more exciting stuff with it. So here in this case, we would basically know that if something, now don't get thrown off by the fact that these are more complicated than this equation here, it's still something divided by something equals something. So if this number divided by this number equals this number, then that means 10 times 2x plus 3 must give me the thing that I'm dividing. Okay, well, so this just becomes now, I have no more denominators left, so I can distribute. So I'd get 20x plus 30 equals x, and well, now we just need to isolate x. Now I notice that there are no squares here, that these are all just linear functions, and we know that from looking at the rational function here. It's a linear divided by a linear, or order 1 divided by order 1. So I need to get x by itself, of course. So what I'm going to do is, you can go a couple of different ways here. I want to get the x's on one side, so I'm just going to go ahead and subtract 20x from both sides. So that removes that guy, and I'm left with 30 equals, well, x minus 20x would be negative 19x, and then I would simply divide both sides by negative 19. Now I should, of course, be able to check my work. If this value that I get, 30 over negative 19, which you can plug that into your calculator and see what it is, if I put in 30 divided by negative 19 back in for x, I should get 10 for y. If you round it, of course, you might get close to 10, but it might not round exactly. So let's look at a problem involving our situation here. So we know that in the oil spill, here's the equation. Over, let's see, this was negative x plus 100. Okay, so in our problem, we want to know there's a $5 million budget to clean up a coastal region of the spill. What percentage can we estimate will be cleaned up? Well, we know in our ordered pairs that x represents the percentage and y represents the cost. Well, what I know in this scenario is the cost that I can afford to pay would be let's change this, let's make this 5 billion because it's in billions, so we don't have to convert it. $5 billion, and the percent that we want to clean up is unknown. We want to figure that out. So in place of y, I'll put 5, and in place of x, well, I'm not going to put anything because I need to solve for it. Oh, there's supposed to be an x there. So I get 5 equals 0.08x divided by negative x plus 100. Okay, well again, if something divided by this equals 5, then that means 5 times this should equal 0.08x. So the logic, of course, doesn't change there. And now we would distribute, so we would get negative 5x plus 500 equals 0.08x. And I'll proceed as before. I'll add 5x to both sides. And so I get, those cancel out, 500 equals 5.08x. And so now I should just be able to come over to my calculator and take 500 divided by 5.08, and I get 98.4. So I can do pretty well here. I can get about 98.4% of the spill cleaned up for this budget. Not too bad. In the calculator, just to emphasize how we would do it, is if you were to plot your output of 5, just as we've been doing in the past, and we graph this, we basically want to figure out, change my window back to 0 to 110, and 0 to 8, we want to figure out where do these two functions intersect. Well, it appears as though that function doesn't go all the way up, but it does. So second calc, intersect, enter, enter, guess.